What's up, guys? April 23rd today. Technically April 24th, 12 a.m. But we back at it again on the grind. Just came back from basketball. Got that health gains. And then this morning I ran a 3K, got that cardio gain. And then my girlfriend just gave me shit for not being proactive with planning, despite me planning everything and not planning for the weather, I guess. So it be what it do. I asked her what she wants to do. She didn't say anything. She just said, I want you to be more proactive with planning. So whatever I plan, she won't be able to say anything. She can just shut the fuck up. Um, yeah. We plan for picnic on Sunday. If it's cloudy, then perfect. Cloudy is like perfect weather for a picnic because it's not too sunny. It's not too you know, um, hot. You want it to be a breezy, like spring weather for picnic, right? But we're going to summer in Hong Kong and it's so hot and so humid. So we'll see about that. If the picnic doesn't work out, then we can go to the Minecraft movie because she wants to go. She said she wants to see the Minecraft movie, so we can do that. And she's also on her period, so it's like you don't want to be moving around that much. Or we can go Science Museum is also something that I would want to go. Um, yeah, I mean, frustrating, frustrating. I don't know what she wants me to do. I know what she wants me to do, but it's like, yeah, it's whatever. Whatever, whatever, it's whatever, it's whatever, it's whatever, it's whatever, it's whatever. And we're going to Shanghai in May. I have no plan for that trip. I don't even know where I want to go. Oh, I'm just going to see my friend. I plan to lock in every day. Yeah, it's whatever. You just, I feel like whatever. If I speak, I'm in big trouble. I just need to lock the fuck in. I just need to, I just need to work, right? Just need to work. Um, Whatever. Always giving me shit. Whatever. I'm gonna shut the fuck up. All right. Binary search trees. Today, what I did was learned about trees more extensively. I learned about full trees, complete trees, perfect trees, balanced trees, binary search trees, and I also implemented binary search trees myself. I wrote a class with a data field, a left pointer, and a right pointer, and then and also the actual binary search tree class, right? Which is uh, just a class with a root node and a bunch of member functions as well. Specifically, I wrote a insert function which inserts data into the tree. If it's smaller than the root, then it goes to the left. If it's bigger than the root, then it goes to the right, and it uses recursion, as a lot of trees do. And also wrote the contains function, which returns true if the data that you feed into is in the tree, and returns false if it's not in the tree, right? Simple. Yeah, and learned about dynamic memory allocation. Dynamic memory allocation, the heap, the stack, machine code, the static data stuff, like uninitialized and initialized data. So like global variables. I know that on the base layer, it's like machine code, and then it's like global variables, static variables, and then it's the stack, which is super quick. It's just a pointer that moves, right? But if you need to, and the size for the stack is fixed, right? So it's fixed at compile time, and at runtime you won't be able to change the size. But with the heap, it's basically a free pool of memory, and you can keep requesting memory from the heap. But also runtime and overhead is a lot, like overhead is a lot higher when you place memory in when you place variables in the heap compared to when you place variables in the stack. Because stack, it's only one CPU instruction, but if you place variables in the heap, it's like a boatload of stuff, right? Because you have to malloc and then you have to keep track of like what is initialized, what is uninitialized, and you have to free the memory after you're done with it, and et cetera, et cetera. It's just a boatload of stuff, boatload of stuff. So stack much quicker, much less overhead. So you should definitely try to initialize variables in the stack whenever you can, unless unless the stack is not big enough to hold whatever you're trying to initialize. Like for example, if you're doing a game and there's a 50 megabyte texture, right? Then you have to put it in the heap because the stacks simply do not fit. Because usually stack is like 2 megabytes. And what else? And for example, like somehow the stack is unavailable, right? Then you will put it in the heap. Yeah, so that's basically the stuff that I did today. Not a lot, not too little, could be doing more. Tomorrow I'm going to HKUST to study. There is no lecture tomorrow. I was supposed to have a networking lecture tomorrow morning, but the professor is sick or whatever. He canceled the classes for the whole week. I don't even know. So, and with that class, I'm actually learning quite a lot actually, and I really enjoy that class. And I feel like that's very essential, um, especially for high frequency trading and just hacking in general. Hacking is just something that is interesting to me. I don't plan on getting into it. I don't really care for it. I understand that hacking happens every day. There's ethical hacking, unethical hacking. I don't give a fuck. But for high frequency trading is very important. You have to understand how data transmits through the server to your computer and then back. Do you use TCP, IP? Do you use UDP? Do you use fast protocol? Do you use FX protocol? Like these are all stuff that you need to know. Um, yeah, anyways, I've talked about this before. But yep, let's get into it. I want to do a binary search tree question. Yeah, so let's do these. Let's do these. Let's do these. I guess I can do this first. Um, yep. Given an array nums where the elements are sorted in ascending order, converted to a height balanced binary tree. High balanced binary tree is which the depth of two subtrees of every node never differs by more than one. So in this case, you have to put it on the right because oh, it's bigger, right? Okay. I was thinking if it keeps going left, right, then it's not going to be balanced. Um, so how would that work? Um, so just the most basic for in I equals to 0, I is smaller than nums dot size, right? That's plus I. If nums I probably initialize a node first. Um, Node star root equals to new node, and this would be nums 0, right? I think this will work. Um, Okay. And then if nums dot I, this will start at 1 then. If nums dot I is smaller or equals, how does the equal one work? Is smaller equal to root dot data, root dot value, right? In that case, root left will equals to you create a new node. So it should be this, right? How'd I do it? How'd I do it? How'd I do it? How'd I do it? It has to be some sort of recursion. It has to be some sort of recursion. Um, I feed you a vector. I feed you a vector. I don't know how to do this. 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 What is this? Can I do this? Fuck. I actually don't know how to do this. And it shouldn't be too difficult. You're given the root. Okay, I feel like I do know this. What are the constraints? Okay, if value is else a value is smaller than root value, then what you want to do is return search BST. Is that it? And it's smaller, right? Then you would return this. If it's still smaller, you keep going, then you keep going, then you keep going, then you keep going, then you keep going. And you will hit a point where you get null. I think it makes sense. I'm very bad at recursion. Does it make sense? Because this left would be null, this right would also be null, right? Tree node does not refer to a value. Oh, oh, oops. Maybe just do this, right? I think. See? Member access with a null pointer. Right? Can I just do this? Does it not make sense? I feel like it does make sense. Is it this? Okay. No way. Okay, holy shit, I actually did it. Nice. Okay, so just talking through my logic. So if the root is null, right? Let's say you started off and the root is null, then you just return null. Else if the value is 4, then you just return 4, right? Because now you've already made sure that root is not null, so that has to be some value in there. And if the value is equals to the value you're looking for, then you return root. You return this whole tree. And else if a value is smaller than the root, then you would go on the left side and search, and you would make the root this root, right? Return search. And if it's bigger, then you do it on the right side. You make this, and then you go through the whole thing again. And if it's smaller, then you go through the whole thing again. And let's say you're here, right? You're here now. And then you're looking for a value even smaller or bigger, right? I don't know. Let's go smaller for the sake of the argument. You go smaller, because you check this, it's not null. You check this, it's not equals. And now you check this, yep, it is smaller. Then you would return search root to the left, right? To the left, which is null. Then when you hit one more stack, you'll return this. If root equals to null, return null. So return null, Return null, return null. So use return null, right? Mm-hmm. Yep. Okay, and it's the exact same thing for the right side. Yep, this one I got. This one I actually got. Great. Yep, typical search tree problem. This is exactly what I did. Uh, yep. I don't know what this is. Okay, well, I did it. So let's go back to like the height balance stuff is what I don't get. Like what if the array is 0, -3, -4, -5, -6, -7, right? Then in that case, just left, 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 left. But you have to convert to height balanced binary tree. Like that is the part that I don't get. Like it's not like I do know how to turn into a binary tree in the like just unbalanced one, but hello, hello, hello. Yeah, yeah, okay, we're back. Anyways, yeah, I'll save this for later. Also, another rant. My Wi-Fi is so bad at home, so inconsistent. Like sometimes it's fine, sometimes it's like the GOAT. Sometimes it's LeBron James of networks. Sometimes it's a goddamn Chris Paul of networks. Or like fucking Dylan Brooks of networks, or like fucking just dog shit role player. Like for example, sometimes it's just it's just like Michael Jordan on the Wizards. You know its potential. You you've seen it be great, but then now it's just a shadow of itself. Like it's just so bad. Anyways, let's see. Fuck. Okay, this one I don't know how to do. Let's try another easy one. This one, range sum maybe 87%. Let's go for the easy ones first because I'm just familiar familiarizing myself with this data structure. Given the root node of a binary search tree and two integers low and high, return the sum of values of all nodes with a value in the inclusive range low, high. Okay. Okay. I feel like this is a traversal problem. Okay. I think in sum equals to 0. Um, sum equals to 0. Okay, I think it's fine. I think it's fine. I think it's fine. Okay. Because it will return a sum, right? It will return sum. Yep. At the end, it will return sum. So what this should do is is if root data value equals to is within yo
JBNT.
yes sir JBBNT you already know
wifi 死咗，所以冇做。
dude this
聽朝
Wi-Fi
咪
man
聽朝7點起身。
this Wi-Fi sucks ass 我聽朝翻學
JB 到幾點啊？
仲喺度 yes
有冇進步啊？呢排 JB
有啊有啊，不過呢個唔係好識個，呢個 I'm still working on it。呢個今日啱啱學，so I don't really know. Very hard. Not that hard.
OK that's great。
I suck ass。我個新止汗劑啊，你做咩試啊？爽身粉味啫。Okay. Okay. Okay. All right. And then it's not else if because I still need to do it. If root value oh, then I have to traverse on the left side, right? Traverse on the left side. Traverse on the right side. I think. We'll check this node. If it is within, it'll add it. It will traverse to this side. If it is equals, it will add it. Traverse to this side, this side, this side, this side, this side. Nah. Oh, fuck. Deal. I keep doing this. Oh my god, I'm getting better at this. I'm actually getting better at this. Holy shit. Does it work? It does work indeed. Holy shit. Okay. Okay, let me talk through it. Sum you start with here, sum equals to 0, and if root is not null, if root is null, then it's just 0, right? Then you return sum. If root is not null, then you go through it. If the root is within the range, then sum will plus this value, and then it will traverse to the left side, and then check the same thing, traverse to the left side, and then check the same thing, and then traverse to the left side until you get root is null, right? If root is null, then sum will be 0, 0. Then you will add it to the previous sum, add it to the previous sum. It will check the right side here, but it's null. So add to the previous sum, come back, add it to the previous sum, come here, add to the previous sum, and then blah, 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 blah. Same thing, right? So it should go like boom, 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 it's dead, boom, dead, return, come here, left, dead, right, dead, come back here, right, and then check this, and then left, dead, it goes to the right, and then left, dead, right, dead, comes back, comes back. Right, that should be the order of traversal, I think. Well, I'm pretty sure I'm right. Yeah. Let's see it. Let's see the south. Depth first. Current value. Yeah, I mean it. Wait, that's what I did as well, though. Wait, this is kind of what I did, though. Wait, hold up. Did I fuck up? Am I not supposed to do this? I mean, they're just shitting on these answers, but I don't know if it's good. They all use this. I mean, like, it looks some lambda bullshit. Like, I don't know. Like, it beats 97 and 25. Mine was what? Beat 160. Wait, mine is pretty good. Is it not? Still uses recursion. Still uses recursion. Method 2. Okay. Okay, iterative version. Well, okay, whatever. I mean, Jesus, what is this shit? Okay, I think I did pretty well here, I think. Um, okay, well, next. Did my girl say anything? I don't know. Sometimes women are just quite difficult, man. Okay. Um, So the same thing, right? I just have an ordered map, and then it's the same thing. I think it's the exact same thing. Um, I'm not gonna do it today. I'm gonna leave it for like someday. I want to cheese this this thing. You get it? You get it? Come on now. In order. What does that mean?